Hey everyone, this is Dan, and today we're going to talk about chops. It's not going to be a pretty tutorial, but it's going to be very important because there's a lot of things we overlook when it comes to chop networks, and there's a lot of issues that can come when we don't pay proper attention to our chop networks. Future Dan here, longer beard, new camera. I just want to say, after having recorded this is going to be a multi-part workshop series. In this first one, we're going to talk about really the basics of the difference between a frame and a sample, and also how they relate to sample rate. And then in part two, I think that's going to be the most important one. It's going to be useful for anybody because we're going to talk about time slicing and losing frames. What happens when you're losing frames with your chops? It's not the end of the world, actually. You can recover data and use lost frames also in your chop processing. So that's going to be very important. In part three, we're going to talk about cooking with chops. It's going to be also pretty important. What does overcooking, undercooking mean in the world of chops? And in the rest, we're going to take a look at some interesting and practical examples with chops that you might have not seen. For example, the feedback chop, we're going to use it in some cases. I'm sure most of you haven't used that. There's going to be a few of those. And then also I'm going to list a few underrated chops that we should be using more. So if you feel like you have a good grasp on the basics, so you know the difference between a sample, a frame, and what sample rate has an effect on, then you can skip to the next part. And if you like my content, please consider subscribing and following me on Patreon also. There's a lot more there, even on the free tier. I'm going to share on my Patreon some very cool chop base comps that I created. One is the constant, which can be any kind of type. So normally the constant chop is just a float. Here we can have a constant comp, for example, a constant string, as well as a chop process, which combines some of the most used chop operators into one comp, as well as a chop bank, which is kind of the fusion of the previous two. So you could be just using the chop bank instead of these two. But most important, we're going to learn how to deal with chops better. We're going to start from the basics, obviously, so that we can have the same vocabulary. And even when it comes to the basics, there are some pitfalls when it comes to chops that we don't always realize. First thing to note is that all chops are calculated on the CPU. There's two groups of chops. One are the generators, which are the darker green, and the other are the filters, which are the lighter green. So normally the darker means that they generate data either from an external device or from your computer, and the lighter ones process data. A very good friend in TouchDesigner is always going to be middle clicking on operators. I do that all the time in every operator family. It's super important that we middle click as much as we can when we are looking for information or trying to find issues. So if you middle click, or if you're on the touchpad, you can Alt or Option right click. We see a lot of information, the name of the operator, the type of the operator. If there's a comment, this one has a comment, which you can add here. Also, it tells us how many times this operator has been cooked, what the cooking time has been on the CPU and on the GPU, and which frame on the timeline was the last cook. A small note when it comes to the cooking time on the CPU, we have 1/60 seconds, which is 16 milliseconds in one frame. So all our operations need to complete under 16 milliseconds. Also, TouchDesigner is largely a single-core, single-threaded application, which means that these operations don't run in parallel, they run after one another. So this is cumulative. So if something takes 1 millisecond to calculate and you have 16 of those, you are very likely to start losing frames because your processing doesn't fit into one frame time. Of course, then you would normally change your frame rate to 30 FPS, and then you would have 33 milliseconds. But it's also our goal not to have to do that, so we're going to be talking about optimization as well in this video. We can also quite easily simulate this and check this. There's a chop called Hog CHOP, which simulates load on your CPU. So now it's set to 0.01 seconds, so 10 milliseconds, and that's going to show up here as CPU cook time approximately 10 milliseconds. So if we reach around 16, we said for 60 frames, we immediately start losing frames. Actually a little bit less than 16 because we're already using some CPU for running the project and everything. So even if I go to 13, let's say, or 12, we already start losing frames. And this is cumulative. So if I do 0.07 here, 0.007, and then add another one, they're going to cumulatively add together. So when I just have one of them taking 7 milliseconds, that's fine. But if I have another chop that's taking 7 milliseconds, we are getting over our total frame time. And we're going to be using the Hog CHOP quite a lot today because we will need to simulate, load, and see what happens with our chop network when we lose frames. This is something I do a lot when developing installations and visuals. I always try to check what happens if I start losing frames, because in certain situations, the errors or like the frame loss can actually accumulate on itself, as we will see with time slicing. So it's important to test our network. And because I hog my network quite frequently, as weird as it sounds, I built it into my toolbar, which is free on GitHub. There's a lot of tools here, not only from me, but from other creators as well. There's a whole wiki. There's also some explanation videos. And if you click on this little piggy icon, we can just activate it here. I'm going to be using it so much, in fact, that I have it mapped to my MIDI controller. So back to our chop anatomy. The main two building blocks of a chop are the channels and the samples. As we probably know, a chop can be multi-channel, can be single channel, can be single sample, can be multi-sample, and the combination of these. Right now we have here a pattern chop that creates 3 channels. We can create the 3 channels by specifying the channel names here with the square brackets. I could say also T1 to 3, and then they would be named such. And it has also specified here 1000 samples. When we middle click, we see 2 numbers here. So we have start and 0 to 999i and 1 to 1000f. The I is the number of samples, and the f is the number of frame information it contains. And we're going to clarify that in a second, what's the difference. And it also says here 0 to 16.67 seconds, which all this comes together and ties together when we start talking about the sample rate of a chop. The sample rate in most cases will be set to your project's frame rate, which is right now 60 frames. So it's 60 samples per second. It's going to be different, for example, when I bring in an audio file in, that's going to have a different sample rate and a different I and F numbers, as well as a different second number. And if we go back to our pattern, the only difference between these two patterns for now is that I set the sample rate for the right one to 30 frames. And the difference when we look at the information here we still see 1000 samples. This is the 1000i. Here we have now 2000 frames. And then here we have 33.33 seconds of information. And that comes from these 30 samples per second. So the math here is basically, if we take a calculator, if we take 1 over 30 and then multiply it by our 1000 samples, it's basically 33.33 seconds of information. And we get to the 2000 frames if we multiply this by 60, which is our original project sample rate, then we get 2000. Or if you look at it from the other direction, we have the 1000 samples, which we set in our pattern here, and we multiply it by the ratio of the chop's sample rate and the project cook rate, which is 60 over 30. And then we get to 2000 frames. So why is this frame information important for us? Why do we need it? When do we need it? And let's say that I wanted to play back this pattern as an animation for something. I could use a time slice chop. We're going to talk about time slices in more detail in a second. Or I could, for example, use a trim chop and then set this to current time slice. You've probably seen this done in some tutorials, and that will output the current time slice according to the timeline. So what's happening right now is that I have my timeline set to 600 frames. If I input this here and I actually change my timeline to also 1000 frames, then what we will see is, depending on where I am on the timeline, I can scrub this animation, and then it reaches to the end, to the value 1 as such. If I do the same with this other ramp, what we will see is as we reach to the end of the timeline, we only reach to the halfway point, to 0.5. And that is because it contains 2000 frames of information. So if I set my range to 2000, then this will also play fully. And what we see now on the first pattern chop is that it will repeat after 1000 frames. it will repeat. It's not a given that it repeats, and that's because of the extend type. So right now the extend on this channel settings is set to cycle. We can set it to mirror on the left or mirror on the right, and then it will start playing backwards after 1000 frames. We can also see the effects of the extend condition here with a S-curve and the lookup with the speed. So when we don't have the extend, the S-curve has an extend hold. So whenever the lookup index exceeds 1, it will hold the last value. And if we set the extend with an extend chop, which we can do here explicitly, we can set the behavior to mirror on the right side. And actually we could do, for example, a hold on the left side, which would mean if we go the other direction with our index. So let me reset that. It holds because this goes to negative value. This is trying to look up this S-curve left from here, and then it's holding the 0. We can also see this on our viewer at the end. If I set this to, again, to cycle, for example, and mirror here are also cycle, we can see the extend condition shown. So this is another building block of a chop, the extend. And then it all ties together. 33.33 seconds is the length of our timeline right now, so it can play this full animation. Or 16.67 seconds for our 60 sample rate animation, and then it can play it twice because it's 16.67 seconds. But it's important that this chop still holds 1000 samples. If we take this to the extreme and set it to 1 sample per second, then we see that this is playing back super slowly, and because it doesn't have the actual sample information, it's gonna be stepping each value of those 1000 samples that is right now stretched to 1000 seconds. We're going for broke here, so let's see further how can we actually restore this. If we maybe get an animation channel from somewhere outside, maybe from another software, we can do a resample, and that will actually quite easily fix that, because the resample by default will do a linear interpolation between those stepped samples. We can also, by the way, turn this off from time slicing, so we get the full output, and then we can change this to new rate and same index range, and then we actually essentially get back our original pattern with 1000 samples and 1000 frames. We can also look at a single sample chop like the LFO. We'll see that it holds 1 sample, 1 frame, which is 0.02 seconds, which is 0.01667. And one very last thing to note here is why is it going from 0 to 999 and this goes from 1 to 1000 here? Well, in TouchDesigner, the frames are indexed from 1 and samples are indexed from 0. So that is really the difference. Here's another example with time slicing and extend. So I'm using the record chop to record my mouse movement. As you can see, the range of this animation chop is from frame 408 to 855. That's when it was on. And when I play this back with a time slice chop, it is only moving, it is only producing something between those frames when it was recording. Outside, it shows the held value, and that is because of the extend. It has hold on both ends. So if I turn on extend and make it cycle, then it cycles. Or if I wanted to, for example, shift this to the beginning of my timeline, then I could use a trim chop and here use shift start to 0. And then the animation starts from the first frame, as you can see here. Of course, you can also play back this animation with a constant and the speed. That's another option. And a little fun fact that some chops, such as the pattern chop and the LFO chop, among others, have special members, which are the chain index and the sample index. And we can use this, for example, to have a different amplitude based on which channel it is. So I could say here in the amplitude that me.chan index should be the amplitude. So for the first channel, which is index 0, the amplitude is 0. For the first one, it is 1, and for the second channel, which is the third channel, is 2. And this is also how we can create a 3-phase LFO. if we type in me.chan index divided by 3 and set the channel name or the number of channels to 3, let's say chan 1, 2, 3, and then we have a 3-phase locked LFO. Now we know better what the relationship is between sample rate, frame, and sample count when it comes to animation. So we've been dealing with animation ideas so far. What about audio? Because as I mentioned earlier, this is a totally different frame count and sample count and sample rate from our project cook rate. Audio files are typically 44.1K hertz sample rate, so that is what we see here. And how do we get actually the 735 and how does it relate, or why is it that? So if we bust out the calculator again, if we divide 44.1K by 60, which is our cook rate, that is 735 samples. And that is because to play the 44.1K samples of 1 second from this audio file, because essentially what it means that in 1 second there's 44.1K audio samples. So to play that under 1 second, which for us is basically divided to 60 frames per second, we have to play 735 samples. So when and why does this matter? Let's say for whatever reason we wanted to lag this chop. So we can do that. There's no problem there. We can even listen to it if we put an audio device out. Well, without, we obviously hear the music itself. With the lag, let's make it much smaller. We can still hear it. It's kind of a low pass filter, as you can hear it. We can also lag per sample, which in this case is gonna be a different result. It's kind of cool in itself also, as such. But what if we wanted to hear this resampled one? Obviously, or maybe not so obviously, we won't be able to hear anything because the audio device out expects 44.1K. If you put a lag to the resampled audio, we will see that it actually looks different. The result looks different, and that lies in the parameters. Now both of them are set to 0.2, but they look different. Why is that? Because they are set to seconds. If I set it to, for example, fraction and set both of them to 1, then we see that the result is the same actually. So we have to kind of keep that in mind, that we would have to use different numbers if we suddenly resampled our audio, which is obviously only true if we use the unit drop down here that differ between these two lags. So basically the frames and the seconds. As you can see, the samples, of course, are the same. So it's also taking the same amount of CPU cook time for both. I wanted to also make a small note when it comes to the audio spectrum, because this is something I see in tutorials, that people put a resample before their audio spectrum. Well, the only thing that it does really in this case is because the output length is set to match length to frequency, then the number of samples that are processed are different, so you have also a different cooking time for both. If we actually set these to set length manually and then the length is the same, 2048, then we have the same cooking time for both of them and the same amount of samples also. So that's what really matters here. It doesn't matter if there's a resample before. But just as an example of optimization, do you really need this many samples of frequency? So should you keep your audio spectrum settings to its default and without resampling? We keep the resample so that the audio spectrum here is only 30 samples as opposed to 22,000. And we can put an analyze after both of these, look at the RMS power, so basically the power of the frequency spectrum. We can also do a difference between them to see if there's any difference. And let's look at the trail of these values. As you can see, the shape is quite similar. This is the high sample count and this is the lower sample count frequency spectrum. So we actually don't really see much difference. There's a difference in amplitude, but it doesn't really matter for us. So in this case, we could easily go with the resampled one, and then we would spare ourselves 0.100 milliseconds or more. I also wanted to point out this difference when dealing with the audio spectrum. So if we set the scaling to frequency, then for the top one, for the big sample count one, we can set a trim to absolute, and then we can hone in on certain frequencies. So this is 1000 and 2000 hertz band that we are analyzing. For the other audio spectrum, where we have more efficient cooking and less samples, of course, we cannot do that because we don't even have that many samples. So what we can do then is, if we disable this resample and set the length manually to, let's say, the lowest that it can go, actually 128, then when we middle click, it tells us that multiply any sample by 172 to get the frequency at that sample, which somehow in practice means that if we do the same trim absolute and want 1000 hertz and 2000 hertz, we have to actually divide by this 172.27 to get the same frequency range, sort of. As you can see, obviously we have much less data, but does it really matter? Again, the shape still remains the same. So we can easily use this, and we spared ourselves about 0.100 milliseconds of cooking time, which is not a lot, but all these small things add up quite quickly. Just to really cover everything, let's say that I wanted to play a sine wave from TouchDesigner. We have for that a very handy audio oscillator, so we could easily do that. This is already in audio sample rate range, so we can simply connect that, and then we hear the sine wave, but you could actually play any chop as audio. How can we do that? If we connect a pattern chop to this audio device out, we don't hear anything. Again, the issue is that the sample rate is not correct. So if we set the sample rate to 44.1K, then we start hearing it. It's quite a low frequency. There we go. This is quite high. Yeah, there we go. We can do the same with the noise, by the way. So we can have our custom noise generator. So this can be quite fun to play around with any kind of chop. A very tangential small side note here is when we output a pattern chop that is ending on the same sample, or is starting on the same sample that it ends on, we get a nice sine wave. Same with the 10 cycle one, because it fits perfectly into one buffer. As soon as I start to change this cycle to something that doesn't perfectly fit, so 11, anything integer is good, but let's say I want something like this, then we hear it gets noisy, and there's also some extra high frequency information there that is not really cool. And we get this general clicky sound. Well, that's because it doesn't end on the same sample. So there's actually a high frequency jump that happens in the audio. So that causes this clicky sound and more high frequency information in our spectrum. Side note, end. Okay, I'm really tired now. So this is part 1. Part 2 coming soon. We're gonna take a look at time slicing. What happens when we lose frames and we are time slicing. Null, cooking with nulls, forcing cooks, selective cooking, and cooking in general with chops. Then a lot of practical examples where we take a look at how we can use some underdog chops, such as the feedback chop, and a lot of others. And then I'm also gonna introduce the Patreon exclusive comps